Welcome at Ask the Professor. The first time is this MOOC and we are all about 1500 students all over the world, so I'm very proud and welcome to you all. I see a good discussion already, so I like that very much, and I like to go on with some questions I saw already in the week 1. So let's talk and let's discuss in the right minutes after this, and let's see what I can do and keep on going with these discussions I really like. The first question was about how to make a track design. What is the best way, what's the best sleeper, what about an alignment, and what about the foundation? And I think there's a lot of right and good parameters you raise these questions, because you need first a good foundation. Otherwise, like in Holland, half of Holland is a swamp, more or less. We have a lot of peat, and it means a lot of water and everything is swimming around if you don't make the right decisions to make a right foundation. So the foundation is very important, like your house. You don't build your house just on sand and then let's see what happens. So you have to be very careful and a lot of money, because foundation means a lot of investments to make a very good foundation. You need a dike, you need to get rid of the water, and that's a lot of important parts in this foundation. Very costly, but very important for the long run to have a right track design. When the foundation is right, then we need the right materials, the right design, the right engineering on it, and also the right alignment. So you have to see, okay, I can make a straight line from A to B, and let's see what I see, but sometimes you have a mountain or you have other things, and then maybe it's better to go around it, or maybe around the swamp or around water. So it's up to you and make the right decision, and also the right budget for it. So it's not that easy to see and look at the map, okay, let's make a line and that's it. So that you also see that in the world map. Please make your own design and you will see what happens really. On the other side, we also have the train itself, the load of course, and the load, that's also important, because more load means you need more bearing capacity, and that's also not easy, because when you have more load and you have not the right foundation, so you need a very robust system to give the right resistance against this load. So it's not that easy, and I think you will see that also in the next weeks in this MOOC, and when you like to get more about this, there is also a professional education after this MOOC, so don't worry, there is follow-up to learn more. So the next part is, of course, when you have this foundation, you have the right sleepers, the right geometry, then you go to the train, because the train is the load, and how to manage the train. And how is the train made of? And of course you have these bogies, you have these coaches with the 2 bogies, and the bogie has a wheel set, and the wheel sets are more or less connected to the bogie. That was one of the questions. How is this wheel set, that's just an axle with 2 wheels in one part, how is this connected to the bogie? And that's very simple. That's by the axle box, and you see the axle box with the bearings. That's exactly the point, how it is connected to the bogie, and then it's connected to the vehicle. So it's only a few small pieces which makes the real right connection with the heavy load on it. So you can imagine that these axle boxes are really, really important to keep them in shape and to control and maintain them very well. When you don't do it, you get hot box. Also you have this hot box detection, because it can burn away, and then you have a derailment. So you don't like this happening in the real world. So that's exactly how it works. Another way is, what is the highest speed? I saw in one of the discussions, the highest speed you could have. Yeah, there can be any speed, you could say. You can be supersonic, but that's a lot of energy you need to go through this high speed. But the other way, when you say, okay, what is more efficient? What is the best speed you could have? I think every speed you could manage, but when you really look to the physics, you have to go through the constraints and the resistances. And what is the highest resistance? It's not the rolling resistance, because we have wheels from steel running on steel, very low resistance. That's why we have so much load per wheel or per axle. So that's good. But on the other hand, the only resistance you have, more or less, the biggest resistance is air. So when you like to have more speed, then you need a double or a quadratic more energy. So you could say, what is the most efficient speed? You can see it more or less on the high speed lines. You see 300, maybe 400 kilometers an hour in average. It's easy to achieve, it's robust, and also when you look at the energy level, it's okay to manage. So when you like to have a real efficient speed, high speed line, I would say something between 300 and 400 kilometers an hour. Another question about vehicles was really nice to see, because you already are triggered about Hyperloop, about hydrogen to use instead of the gasoline. So I think that's really the point. We are more or less in an energy transition, and don't worry, it will come. But everything what will come in railway is always time. It's costly in time to manage and transition. You could say why? And that's also very easy, because when you like to transfer to a new idea or a new concept, it always takes a lot of time, because the infra and assets of today, you don't throw it away just in a few years. So there's a very long life cycle, so you invest for 40, 50 or even for bridges 100 years, and you don't throw it away. So when you make a decision today, you will get a lot of headache or a lot of joy for 40 till 100 years. So when you like to have a transition, that also take a lot of time. So a full transition from now, you could say, to everything hydrogen or maybe Hyperloop, it will be 50 or 100 years. So that's life in railway business, and you cannot change it, or you need somebody who likes to invest and to change everything in one run, and then even then it will take 10, 20 years. So honestly, the hydrogen, it's already there. It's technique of today. It's just to roll out, and the business cases are there, so I'm not worried. It will come easily. It's just a matter of time, as explained. But the Hyperloop is a different part, because the technique is not ready yet. It's in development, so the research part. But now you also need a full new infra network. So you have to make the tubes, you have to design it, you have to go through cities to the landscape, and that costs a lot of money and a lot of CO2. So I don't think it will come easily. It will come, but I don't expect it will be everywhere in the world. Maybe some corridors, but let's see what happens. It was a nice question about the governance. Will there be some way or some moment a one European railway network? And of course, it is already there. But when you look in the practice, there's the problem. I think when you look at the TSIs and the normatives and the ISO norms, it's already there. It's only how to make it happen and to cooperate with each other. So how to cooperate with every country. And you could say, yeah, that's easy because we have a European Union and let's make it happen. But I think that's the problem, because railways is always connected with the national government, and it is sponsored or paid by the national government. And that means there is no market. And when there is no market, there is no push, you could say, to be united and to earn money, for example. It's more a public transport. It says already in the word, it's public, so it is from everybody. And that's not easy to change and to move very quick in a one-way direction. And as I told before, it's always not easy, because it's very high price assets. So when you like to change, for example, the power on the catenary, you don't change it one day to another. So you have the full infra of this energy transport. You cannot change it, and it will take 10, 20 years. So when you say, okay, in Holland we have some corridors with the European normative, like 25 kilovolts, but that's only a few lines, because it will take many years and a lot of money to invest to change everything. And also you have to change the locomotives as well. So it's not that easy to say, why not shift in a few years? That's the problem. The time is the problem, the budget is a problem. And I think when you talk about the theory, it's already there. So that's the good news. So many thanks for this. I really enjoyed the questions, also the discussions. You're very active. I like that a lot. I cannot touch everything today, but please go on with your discussions, and all things and discussions we already have in your mind in week 1. Great, but take it easy. There will be also more information later on in this MOOC. We have 6 weeks, so don't worry. If there are still some open questions you don't see an answer, feel free to go for the next Ask the Professor. So I hope to see you there, and go ahead and keep on track.